All right, in this video, we are given one trig function, one of the, wait for it, 6 trig functions. So we're going to be given one of these, and we're being asked to find the other 5. So we're given one trig function and the quadrant. That's important. And I'm going to show you how to find the other 5. Problem number 4 says that the cosecant of theta is equal to 2, and we're in quadrant 2. Let's take a look. All right, so the cosecant of theta equals 2, and we are in quadrant 2. So quadrant 2, quadrant 2 is over here. So I'm just going to put my triangle in the correct quadrant. So it's helpful to look at this as 2 over 1. Now remember that cosecant is the reciprocal of the sine function. All right, so let's look at those side by side. So the sine function then, maybe I'll just put that right here. So if the cosecant is the reciprocal of the sine function, then the sine of theta, which by the way, here's my reference angle, the sine would be 1 over 2 because they're reciprocals. Okay, now remember the definition of sine is opposite over hypotenuse. So when I'm looking at this 1, I'm thinking opposite, and when I'm looking at that 2, I'm thinking hypotenuse. Okay, so from theta, opposite, do I want to use these colors? Opposite over hypotenuse. Now, we have to be careful about the signs, positive, negative. In this quadrant, the radius is always positive, so that's fine, the hypotenuse. But the y value, is the y value positive in this quadrant? Well, yes, it is, because the y value tells you how high this point is. And this point is above the x-axis, so this should be a positive number. So we're good right now. We're good. Okay. Now, we need to find the x value as well. So the x value, we will use the Pythagorean Theorem to find it. So we're going to go a squared plus b squared equals c squared. So this is like the x value that we're trying to find. So 1 squared plus x squared is equal to 2 squared. So that's 1 plus x squared is equal to 4. Subtracting 1 from both sides, that gives me x squared is equal to 3. So therefore x is equal to the square root of 3. Normally we'd say plus or minus 3, but these lengths can only be positive. However, well, maybe we should think of it as plus or minus 3, because the way we're going to know whether it's positive or negative 3 is by the quadrant. So we know that the length of this side of the triangle is radical 3. So the only question is, should it be positive or negative? Well, this is an x value. Is an x value going to be positive or negative in this quadrant? Well, we're going to the left, and to the left is negative, so this should be a negative radical 3. Putting it all together, actually I don't need to know that point. I take it all back, not putting it all together. Let's go ahead and find all 6 trig functions. We already have 2, but I might do them again, sort of. So I've got sine and cosecant, fine. Let's go ahead and find cosine now. So cosine of my reference angle there is going to be adjacent over hypotenuse. So that's going to be negative radical 3 over 2. Now, the inverse of cosine is the secant function. So I can go ahead and do that. So secant is going to be the reciprocal. Did I say inverse? I meant reciprocal. So that would be 2 over negative radical 3. All right, that just leaves tangent and cotangent. So tangent of theta, tangent is opposite over adjacent. So that's going to be 1 over negative radical 3. The cotangent is the reciprocal of this. So the reciprocal of this would be negative radical 3 over 1. But that's just negative radical 3. So these are the 6 trig functions. Number 5. Let's take, well, we're given that the tangent of theta is 2 and we're in quadrant 1. So let's take a look at that. All right, so tangent of the angle is 2 and we're in quadrant 1. So here's the reference angle right here. And tangent is opposite over adjacent. So for the moment, I'm going to think of this as 2 over 1. So as I look at that 2, I can think opposite. And as I look at the 1, I can think adjacent. All right, opposite over adjacent. So from the theta, that would make this 2 and this 1, opposite over adjacent. Are these the correct signs, positive or negative? Well, is the x value positive in this quadrant? Yes, it's to the right, so that's positive. What about the y value? The y value is up, so that should be positive. So both of these are positive, so that's fine. Now let's find the radius here, the hypotenuse. For that, of course, we use the Pythagorean Theorem. So a squared plus b squared equals c squared. So 1 squared plus 2 squared equals the radius squared. So that's 1 plus 4 equals radius squared. So that's 5 equals radius squared. So the radius is equal to the square root of 5. Okay, so there you go, square root of 5. The radius, hypotenuse, is always positive. So now that we have all 3 sides of the triangle, we are prepared to find all 6 trig functions. Okay, we have tangent already, so let's go ahead and find cotangent, which is just the reciprocal. Okay, so the cotangent of theta, instead of being 2 over 1, will be 1 over 2. Okay. Okay. Uh-oh. Better finish this up. Then I'm going to go up. So let's do the cosine function. All right? Cosine is adjacent over hypotenuse, so that's 1 over radical 5. The inverse, the reciprocal of that will be the secant function. So that would be radical 5 over 1, which is just radical 5. That leaves the sine function. All right, sine is opposite over hypotenuse. So that's going to be 2 over radical 5. The reciprocal of that is called the cosecant. So the reciprocal will be radical 5 over 2. So those are all 6 trig functions. All right, take a look at number 6. We have the secant and the quadrant. So the secant is square root of 3. Okay, so we've got the secant of theta is equal to the square root of 3. Now, what about it? Oh yeah, what quadrant did they say? Fourth quadrant. So let me move my triangle to represent the fourth quadrant. So the fourth quadrant is right here. Now, remember that the secant is the reciprocal of the cosine function. Okay, so that means that the cosine function must equal 1 over radical 3. All right, it's the reciprocal of this. Now, our theta that we're talking about is right here. So remember, cosine is defined as adjacent over hypotenuse. So when I look at that 1, I'm thinking adjacent. When I look at that radical 3, I'm thinking hypotenuse. So from the theta, if the adjacent is 1, okay, and the hypotenuse is radical 3, then these are what we have so far. Now let's be aware of the signs, right, meaning positive or negative. The hypotenuse, the radius here, is always going to be positive. But should this x value be positive in this quadrant? Well, yeah, it is positive because it's going to the right. So far, this is fine. Now we just need to find the y value. So we'll use the Pythagorean Theorem. So I'm just going to call it y for now. So if I do 1 squared plus y squared, that should equal radical 3 squared. Okay, that's a horrible 3. OCD. So there we go. So that's going to give me 1 plus y squared. Now if you square something that's in a radical, the radical just goes away. So now I will subtract 1 from both sides, and that will give me y squared is equal to 2. And if I take the square root of both sides, then that's going to give me y equals the square root of 2. So y is the square root of 2. All right, except for we need to pay attention to the sign. So this is the square root of 2. Now, is that going to be positive like the others, or should this be negative? This one should be negative because this is a y value and this is going down. Like if you're looking at this point right here, this is down radical 2. All right? It's to the right one, that's positive, down radical 2. All right, now that we have all three sides of this triangle with the proper signs, I can do the rest of the trig functions. So for example, the sine function, all right, the sine of theta is opposite over hypotenuse. So let me be real careful about that. Okay, opposite over hypotenuse, so that's going to be negative radical 2 over radical 3. You know what, I'm just going to leave it like that, actually. Yeah, that's it. I'm just going to leave it like that. And then the reciprocal of the sine function is the cosecant function. So cosecant theta is going to equal radical 3 over negative radical 2. So you got that. And now the tangent function. All right, tangent is opposite over adjacent. So that's going to be negative radical 2 over 1, which is just negative radical 2. Of course, the reciprocal of that is the cotangent function. And that's just going to be 1 over negative radical 2. So now we have all 6 trig functions. All right, so that was number 6. Here's the last one. We're given the cotangent, which is equal to 1, and the fact that it's in quadrant 3. So let's knock that out. So this is the information that we're given. The cotangent is equal to 1, And here we are in quadrant 3. Somehow we're going to use this to find all of the trig functions. Well, cotangent, I'm going to think of this as 1 over 1. Okay? We know that cotangent is the reciprocal of the tangent function. So let me go ahead and write that down. Let's see, is this visible? All right, so tangent, the reciprocal of 1 over 1 is still 1 over 1. So looking at theta here, I know tangent is opposite over adjacent. So that's opposite, that's adjacent. So that's 1 and 1. Now, I can look at this and just figure out what the hypotenuse is going to be without using the Pythagorean theorem. The reason why is because I see that this is isosceles, 1 and 1. And so I know that this is a 45, 45, 90 triangle. So the pattern goes leg, 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 radical 2. So this is 1, 1, and this would be like 1 radical 2, or in other words, just radical 2. Okay, so I know that's going to be radical 2. Now, before we get too carried away, we need to pay attention to the signs of these sides. Okay, I'm in the third quadrant. Now, this 1 right here, is this going to be negative or positive? Well, we're on the x-axis here, and this is going to the left, so this is definitely going to be negative 1. What about this y value? Well, this is below the x-axis. We're dropping down. So this should also be a negative 1. Anyway, I could use my special triangle knowledge, or I could have done the Pythagorean theorem and done negative 1 squared plus negative 1 squared is equal to x squared. That would give me 1 plus 1 is equal to x squared, 2 is equal to x squared. But once you take the square root of both sides, you just get the square root of 2 is equal to x. So that's where I got the square root of 2 from, if you're going to do it the long way. Anyway, back to business. Now that I have all three sides, I can find the rest of the trig functions. For example, cosine. Cosine is adjacent leg over the hypotenuse. So that would be negative 1 over radical 2. All right, the reciprocal of cosine is secant. Which will be a negative radical 2. You know, the reciprocal of this is radical 2 over negative 1. But just the same way we don't leave radical 2 over 1, okay, we won't leave it over negative 1 either. Just we put the negative on the radical and we erase the unnecessary 1 in the bottom. Okay, by the way, I'm not going to leave this as 1 over 1 either. The cotangent of theta is 1, and the tangent of theta is also just 1. I just did that so I could make my picture. But in the end, tangent is equal to just 1. All right, one more, the sine function. Sine is opposite over hypotenuse, so that would be negative 1 over radical 2. So that's the same as a cosine function. So notice that the sine and cosine are the same in a 45, 90 triangle. So the reciprocal is going to be the same thing as the secant. The reciprocal of a sine function is called the cosecant. And so when I do the reciprocal, I get negative radical 2. And that's it. And that's going to be the end of this lesson. Hope it was helpful. See you on the next video.